Here's a Coda automation that's being used by a company that produces these big complicated water pumps for mines and for quarries and building sites. And the customer fills out an order form, which is quite a complicated piece of UI using Coda. It doesn't generate an order, it generates a requirement because the customer doesn't know enough to make sure that they've gotten all these different bits and pieces all put in properly. That requirement then goes to an engineer who uses another Coda app to configure what the customer is looking for. And this engineer is an expert and has access to a lot of technical specs, the supplier catalog for all the bits and pieces and the parts. And they've developed their own procedure manuals that explain exactly how to classify the different use cases that people have and build a solution. And from that, they build a bill of materials, which is basically a list of all the parts that need to be put together to make a solution for this customer. And when that's confirmed by the customer, now you have an order, and that goes to a dispatcher in a warehouse who runs a warehouse application, who then pulls out all the bits and pieces and sticks them on a truck and sends them off to the customer. And eventually the customer will get the delivery. There's a delivery docket that says, here's all your bits. They sign off the delivery, and eventually somebody in finance delivers an invoice. This is all bog standard, happy as you go code automation. Could be done in any other no-code tool as well. And what this customer doesn't want, or sorry, what this particular operation don't want is to give their customer a chatbot that says, let me help you build one of these things. They don't want that. They are happy with the customer filling out the requirements form. And they don't want to give the engineer a co-pilot that says, let me help you. Let me look at what you're doing. Okay, I see what you're doing here. Let me, Instead, they want to surgically remove this piece of the process and replace it with an agent so that this will just flow straight through as an automation. The engineer may have a supervisory role and take a check to make sure that nothing weird is going on, but basically you're looking to replace all of this with an agent. Now, the first time I was challenged with doing that, that was more than a year ago. LangChain was the way you did it. So I went into LangChain, learned how to do agents in LangChain, which is a Python-based development system. And so you use Python to
interrupt you just a second. One thing that I thought was worth mentioning is in the slide you had before, because Max has told me about this before, and I just wanted to make sure that's not getting lost. This entire process, the stages are automated, but the task that relates to the engineer still relies on human judgment. So the company did not automate that part at this point.
Yeah, they automated it insofar as they gave a user interface and all the formulas and buttons and doodads are in there, but you still have to have this knowledge.
And that's what you now identified to say, okay, then now let's put AI to the task that has not yet been able to automate.
Yeah. And it's an important point that we're not rebuilding everything from scratch because AI has suddenly popped up. We're saying, no, we're just going to replace this one little piece of, and that means that we get all of our existing tables, all of our existing forms and workflows, all of our formulas, all of our actions, everything stays the same. We're just going to replace this one piece here with an agent. And as I said, the first agents we used were LangChain, and you have to know Python. And so we had to upload all our documents into a knowledge corpus, and that means you're building a custom GPT that does this RAG, this, the whole thing of being able to use the LLM to understand the language of the instructions, but it answers its questions using this body of knowledge. So you build a huge, big, complicated prompt. And if any of you have been involved in building prompts, you quickly get into some very, very sophisticated language. Lawyers, Doug, do very well at this because they're used to writing language with precision and with consequence, right? The rest of us, we're struggling. And you end up with prompts that have more clauses in them saying, don't do this and don't do that. Because when you test it first, it works. And then every now and then it comes up with something, it puts quotation marks, or it says, I'm happy to help you with this. Say, no, stop saying that. Stop doing this, stop doing that. Now, It doesn't have any memory. These language models don't remember anything you're doing. So if it's more than one step, you need to build this object, this memory. So within LangChain, you build memory objects that remember things. You build these tools. And each tool is doing something that the LLM can't do. So this one says, here's how you go to the internet to do a search. This tool might say, here's how you use this API to get the latest data from this supplier. This one might say, here's how to use an API to update a database with the results. This is a complicated procedure that does all of the hydrostatic and hydrodynamic calculations that are needed to work it out, because the LLM can't do any of that. And then you get your output. And your output is normally a big, long, squidgy piece of text. And how do you get the input in? LangChain doesn't help you there. How do you put, what do you do with the output? LangChain doesn't help you with that. So you put all of this into a pack, and that's how you get at it from Coda. We got this working, and the customer wasn't happy. They said, we don't want our citizen developers, our makers, having to learn Python and JavaScript. They already know how to build relational tables and formulas. So why can't we do this in Coda? And after I'd gone around the houses here a few times, I started to notice the pattern. And I thought, this really does map to something Coda is good at doing. Right? And so we ended up being able to replicate all of this, but in Coda, and without doing anything fancy or extra. So you still have to upload your documents. If you're going to use documents in a knowledge base, you upload those into a vector database in OpenAI, and you get yourself a custom GPT. That's fairly standard. It's quite easy to do. Now we're using Coda AI columns in a table to handle all of the AI stuff. And we're using Coda formulas to do the bits that the LLM can't do. So we have a formula for doing an API call, or you have a formula for doing your hydrostatic calculations. We have a formula that determines what to do next and which category things fit into and so on. We don't need memory because we've got everything in our Coda tables. Everything just sits in your Coda. Once you make this change, you suddenly think, this is so much easier. We use our existing Coda UI dialogues and forms for the input, and the output goes to our usual Coda action formulas that say, upload this to this database, change this the way we normally do. So the whole thing becomes an AI agent written using nothing but AI formulas. And in fact, if you're not using a vector database, you can just use Coda AI. You don't need to have a pack. But if you are using a vector database, then there's a little pack that you can use that does practically the same thing. Going to stop here for a moment and see if anybody's got lost in the dust. Or are you all keeping up with me?
No, it's good. It's
Yep.
great. Yeah.
Okay. So let's have a look at these agents that we've built.
Max,
Okay, sorry,
allow
go
me
ahead.
to ask a question, please.
Yeah.
So where you say if we don't use an assistant, so if we don't use a pack if we don't upload our documents to, for example, an OpenAI assistant and then connect it via a pack to our Coda doc, is that in the future where we'd be querying Coda Brain directly?
That's where Coda Brain is presumably going to fit right in, is that we won't have to use a pack the Coda AI will be extended to be able to do that, right?
Understood. Wonderful.
So from here on in, I'm not going to use RAG. I'm only going to use Coda AI or OpenAI directly. The RAG thing gets complicated. I'll leave that for another day. So here's a classic example, a real one from an insurance broker where emails are coming in different languages. The email agent translates these into English if they're of the right language. We're only allowed to use certain languages for legal reasons. And then it passes them over to an instruction agent, which is another table. Every time a new record appears in here, a new row, the instruction agent looks inside the text and pulls out the instructions and creates a new instruction for each type. And then if the instruction is straightforward, it will write out the transaction to the transaction table. And this will eventually get sent up to a mainframe that implements all of the changes that the customers have asked for over here. However, some changes are not so clear and they get sent over to a special agent called a change agent, which then analyzes it and says, well, this is change of cover. This is a change of the type of the policy. This is a change of the value of the policy. And so it creates a different transaction based upon further analysis. And we're using AI because you can't write a formula that does this or this or this, right? It's beyond the ability to use a formula. So if I click on this button to run the agents, you'll see the agents running. The one that's running is highlighted. And so this one starts, it creates these, they run one after another. Every now and then you'll see the new transactions appearing over here. And every now and then one of the transactions is not simple and it goes to the change agent, which then figures out what type of change it is. And so you see the whole thing running here. And it, takes a few moments. None of this is blindingly fast. It will be in the future, especially when you start to be able to download the models into memory. So they'll sit inside your browser. And then when it's finished, all the transactions have been generated. And each one of these is just an ordinary table with AI prompts inside it. But we've orchestrated the whole thing so that it runs smoothly. And you'll see that only one agent is running at any one time. And that's because if you try and do too many AI things at once, the server will throttle you. It'll cut down, and it actually takes longer. It's much faster if you give it just one at a time. Okay. So this is what we've done. Okay, go ahead, Christian.
Yeah. So the change agent, that's Coda AI, or is that a pack of this AI?
No, this is Coda AI. There's no packs used in this. I'm just using good old Coda AI for all of this.
Well,
right?
that's impressive.
Now, I will talk a little bit
Off?
later about the
Sorry.
differences between Coda AI and using a pack. But for this type of stuff, ordinary Coda AI is fine. Go ahead, Nina.
The instruction agent is the one, the email agent hands off the task to the instruction agent. And the
Yes.
instruction agent on its own calls upon the change agent if it says, I can't figure this out, I need to bring in the change agent.
Yeah. So if we go down here, all of these are instructions that it understood. So it has classified them to say, I understand this. It's an instruction to create a new insurance policy. And so it goes over here and it says, here's the type is new, here's the number I want, and here's the amount, right? But every now and then it comes across something where somebody has said, please change the policy due to an increase in the value of my property. And it says, okay, I'm not sure what to do with that. I'll hand it to the change agent, which has different prompts and might actually be using RAG or something more sophisticated to do more work. And it then, so this ability to hand work over from one agent to another is part of how this works. And I'll show you now in a moment how that happens, right? I'm going to use a simple